Hello everyone, this is going to be the sort of tutorial video for lab number 3, lab number 4 of Astronomy of the Solar System, Orbits Lab and Phases of the Moon. There are more detailed videos in Canvas, but this is going to be more a generic video of some of the tools that you need to know how to use for both labs. For lab number 3, you need to change the location according to what the lab is asking you to do. Change the date and time, and then you are going to analyze the elongations of both Mercury and Venus for part 1, and then on part 2, you are going to analyze the inferior conjunction and superior conjunction for Venus and Mercury. And then you will do the opposition for Mars and Jupiter, the opposition and the conjunction for those planets. Now, in the lecture, you're going to be talking about the solar system, the composition of the solar system, the position of the planets, the way they orbit the sun. And this lab should help you not just understand, but also visualize what you're going to be discussing in the lecture. Now, keep in mind that the Orbits lab, you have to pay attention to a few details. One of them is the location. So I want to place myself here on the North Pole. You have to use the location given in the lab. But this should help. At least you will see what's going on by me showing you this. Remove the atmosphere. Make sure you can still see the cardinal points, and then you can remove the ground. So you have the east to the right, and obviously the west to the left. All right. Why am I doing that? Because now I'm going to look at Mercury and then at Venus. Go to sky view options, go to solar system objects, and then check show orbits. That way, if you click at Mercury, you will indeed observe the orbit of Mercury around the sun. The lab is asking you to measure with the angle measure tool the elongation of the orbit when Mercury is on the far east and on the far west. And that's actually not difficult to do. I'm going to center on Mercury, and then I'm going to move time until I'm on the east, or sorry, on the west. And then here I can use, so that's a good approximation there. And then with the angle measure tool, I measure this. It's about 27 degrees, 11 arc minutes, 19.34 arc seconds. Similarly, I can do the same for when Mercury is on the east. So we go to the east now. All right, that will happen, and that's normal because just like Mercury is orbiting the sun, we are also moving with respect of Mercury orbiting the sun. So let's see. Maybe we can play with this a little bit better. I'm going to use the next month, so you can see. So this will be better actually. Okay, so that's at the east, right? If I zoom out, east here. Angle measure tool. So, well, difference there, right? 18 degrees, 0 arc minus, 32.23 arc seconds. The reason you are seeing this difference, you won't see this difference with Venus. We won't see that if we were at Mars, for example, and we were to observe the elongation, to measure the elongations of the orbits of the Earth around the Sun, east and west, you will notice, as we will see with Venus, the differences are negligible or very tiny. For Mercury, that's not the case because, as you know, Mercury has the most elliptical orbit among the terrestrial planets. Between Mercury, Venus, the Earth, and Mars, Mercury has the highest elliptical orbit, meaning that it has a higher eccentricity, which explains why the elongations are quite different. Okay? Let's take a look at Venus now. So it has a larger orbit. For Venus, I have to use the month. So I have to change by month. So there, let's center it on Venus. And then, okay, it's happening what will happen with, no, certainly not that bad. There. So that's at the west. We're going to measure the elongation of the west, far west. (47°, 32 arc minutes, 21.01 arc seconds. If I keep going, so that happens, guys. Let's make sure you click on the moon or click anywhere else. Click on Venus again. Make sure you center it, and then that should fix it. Yeah. So I'm going to place Venus at the far east now. There it is, right? So as I said before, yeah, the elongation is very close to the west elongation. Venus has a very low eccentricity, has an elliptical orbit around the sun, but it's very circular-ish, just like for us, for the Earth. All right? So that's part one of the lab. Part two of the lab, what you have to be careful with part two is the location. So you're going to change your location to Solar System Observer, where it says planet. Here. And the idea is to observe the solar system from the top. So look when I click on Mercury. Mercury. And if I get closer, I can find Mercury. Why am I doing that? Because now I want to find the superior and inferior conjunction for Mercury and Venus. And you will do the same for Mars and Jupiter. You just need to find the dates when that happens. Pay attention to the date and time they specify in the lab. Many students make mistake with that. They look at a random year. You have to look it up at the correct year. I'm doing now 2024 because this, or 2023, this happens every year. But, you know, you need to pay attention what they're asking in the lab. So pretty much, if I move time here, I can align Mercury, the sun, and the Earth. And why is that important? Because right now, I'm showing you the superior conjunction of Mercury. That's the farthest distance from us between Mercury and the Earth. And the inferior conjunction will basically be the opposite, will be the closest approach of Mercury to us. So that's why I'm doing this. Now, keep in mind, this makes sense. According to Kepler's laws, to Newton's laws, Mercury being the closest planet to the sun, it has an orbital speed greater than ours, than the Earth and Venus. So that's what we see. So now the sun is aligned to Mercury, aligned to the Earth. So this will be the inferior conjunction on 2023 on the 22nd of December. So almost on Christmas time. That was the inferior conjunction of Mercury. We can do the same with Venus. Now with Venus, we might have to play with the month a little bit. And then Venus is also orbiting at a greater rate than the Earth. So we can take advantage of that and align the Earth, Venus, and the Sun. So on the 16th of August, on 2023, that's when Venus, the Earth, and the Sun were aligned in inferior conjunction. And I can do the same now to find the superior conjunction. The superior conjunction, we will go to 2022. And it will be around there, right? Well, maybe more like this. Actually, wait. Yeah, that makes sense. Yeah. So around the 24th of October in 2022, that's when Venus was at a superior conjunction at the farthest distance from us. Okay. So that's simple. That's the only thing you have to do for your Orbis lab. You have to take your time because some of these are new measurements, new tools that you're going to be using. But once you get a hand of it with one of the planets, you can immediately do the next one. Okay? Easier for me is I've done this before. You may have to play with the software a little bit. Go on and check the videos I have uploaded, both in Canvas and in here. All right? And now we can proceed with the 4 lab. Now, the next lab is actually not that bad. The next lab is just observing the moon. So I want to change the location. I want to go back to Earth. There. And then, let's look for the moon. If that happens, guys, that's because it's below the ground, below the horizon. So there you are. Let's remove the orbits now. We don't need that anymore. The idea with this lab is to observe the phases of the moon and answer questions based on what you observe. The pattern, the illumination, which is here. The illumination is a very important factor for lab number 4. It will allow you to understand why phases happen and how do they happen with respect to the sun. How does the sun and the moon, and obviously us here on Earth, play a role on observing those phases? Why they happen? Illumination is basically the key. You're going to be exploring the moon in a particular date and time, and you're going to be looking at the moon for 1 full month. So you're going to be looking at the moon going on waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, and new moon. Okay. This lab, you have to complete a table. That might take you the longest amount of time. After that, and once you do the graphs that are required for this lab, you can start answering the questions. Okay. Now, to answer the questions, make sure you observe your graph, you look at the table. You can go back and take a look at the phases with the stellarium. And then on the last page, you have to explore the lunar and solar eclipses. You have to answer a few questions regarding that, and you have to find, you can Google some dates, but you can actually find eclipses that have happened in the past, and then discuss about what you observed. So lab number 4 is actually quite simple. I do expect students to complete that lab and submit it on time. If you have any questions, please feel free to email me, to message me, maybe place a comment on this video so I can take a look at it and answer your question. But I hope this video helped you with this. Again, lab number 3 is all about orbits. Make sure you read the lab, you write down the location properly. And with lab number 4 is just basically exploring the faces of the moon. Okay, so feel free to contact me, and I will see you guys on the next tutorial video where I will be going about the other labs that are related to the extragalactic astronomy beyond the solar system. There are a few labs where you have to do some math. That one I think is more self-explanatory. Make sure you ask your lecturer just in case, or if I'm your lecturer, ask me or what you have to do. But in the case of the observational labs, the stellarium labs, I'll be posting a few videos about some of those labs, so it's easier for you to navigate once you get your hands on them. All right, so I will see you all later. Have a great day.